Hello everyone. Today we're going to be doing scale factors, volume, and surface area of 3D objects. First we're going to do a little bit of review with scale factors and areas. So we need to complete this table. In the first row we have a rectangle with an area of 450 meters squared, a scale factor of 1/3. Because 1 divided by 3 would give us 0.3 repeating, that's between 0 and 1. So the scaled area would be smaller. The scale factor squared would be 1/9. Because 1/3 times 1/3 is 1/9. And to determine the scaled area, we divide 450 by 9, giving us 50 meters squared. In the second row, we have a circle with an area of 60.8 meters squared and a scaled area of 15.2, squared meters. So we can determine the scale factor squared by going 60.8 times k squared equals 15.2. We figure out k squared by dividing both sides of this equation by 60.8. And 15.2 divided by 60.8 gives us 1/4. So if we square root that, we get the scale factor, so that would be 1/2. If we square root 0.25, we get 0.5. And the scaled area compared to the original area, because the scale factor is between 0 and 1, is going to be smaller, which we can also see with comparing 15.2 with 60.8. In the third row we have a right angle triangle, a scaled area of 1,250 square feet, and a scale factor squared of 9/25. We can determine the original area by going area times k squared, which is 9/25, equals 1250. We solve for area in this equation by dividing both sides by 9/25, which is equivalent to multiplying by 25/9. So 9/25 divided by itself is just 1, and 1250 times 25/9 gives us 3,472 centimeters squared. We can determine the scale factor k by square rooting this number. The square root of the numerator is 3, and the square root of the denominator is 5. Given that the scale factor is between 0 and 1, amounts to a reduction, so the scaled area should be smaller, which we can also see if we compare the original area to the scaled area. Next we're on to volume and scale factors, and we need to determine the volume of the rectangular prism shown. So the volume of a rectangular prism is given by length times width times height. The length is 4, the width is 12, and the height is 8. And 4 times 12 times 8 gives us 384 centimeters cubed. Next we need to complete the table. The scale factor applied to the prism of 2 would give us an adjusted length of 8, an adjusted width of 24, and a height of 16, giving us a volume of 8 times 24 times 16, which gives us 3,072 centimeters cubed. If we divide that result by 384, we get 8. Next we need to cube the scale factor. So 2 cubed, 2 times 2 times 2 is 8. And if we multiply that number by the original volume, 8 times 384 gives us 3,072 centimeters cubed. With a scale factor of 1/4 in the next row, the new length would be 4 divided by 4, which is 1. The new width would be 12 divided by 4, which is 3. And the new height would be 8 divided by 4, which is 2. If we multiply 1 times 3 times 2, we get 6 centimeters cubed. And if we divide that by the original volume of 384, we get 1/64. If we cube the scale factor, 1/4 times 1/4 times 1/4 is 1/64. And if we multiply that number by the original volume of 384, we get 6 centimeters cubed. Now we need to find the volume of the sphere shown. We have a diameter of 8 centimeters, so that means the radius is half that, so 4 centimeters. So if we plug in what we know, v is 4/3 times pi times 4 cubed. 4 cubed is 64. We do that first, and then multiply by 4/3 and multiply by pi. We get 268 centimeters cubed. And now we need to complete the table. If we multiply the radius by a scale factor of 3, the original radius of 4, if we multiply by 3, gives us 12. 12 cubed times 4/3 times pi would give us 7,238 centimeters cubed. If we divide that result by the original volume of 268, we get an answer of 27. Remember, we need to have the units of the scaled volume and the original volume to be the same. The scale factor cubed, 3 times 3 times 3, is 27, and 27 multiplied by 268 gives us 7,238 centimeters cubed. If we scale the radius by 1/2, 4 divided by 2 gives us a scaled radius of 2. 2 cubed is 8, and if we multiply that by 4/3 times pi, we get 33.5 centimeters cubed. And dividing 33.5 centimeters cubed by 268 centimeters cubed, we get a result of 1/8. The scale factor 1/2 raised to the power of 3, 1/2 times 1/2 times 1/2 is 1/8 as well, and 1/8 times 268 gives us 33.5 centimeters cubed. So in both tables, with the rectangular prism and the sphere, if we compare the scaled volume to the column labeled scale factor cubed times original volume, you should notice that they're the same. Now we're looking to determine the volume of the trapezoidal prism shown. We need to find the area of the trapezoid first. This is h1, and then we multiply by h2. A and b are given here. Because addition is commutative, you could also label A as 18 and B as 10. Now we need to determine the height of this trapezoid. Assuming this is a right angle triangle, we need to get the opposite length, and we have the hypotenuse, which means we need to use sine. So sine of 40 equals opposite, which is h1, divided by the hypotenuse, which is 7. So h1 is 7 times sine of 40, which is 4.49. So now we can figure out the volume. Volume is 1/2 times h1, which we just found, multiplied by a plus b, so 10 plus 18 is 28, multiplied by 20. So 4.49 times 28 times 20 times 0.5 gives us a volume of 1,259.9 centimeters cubed. If a scale factor of 3 is used to draw a new trapezoidal prism, so all linear measurements are multiplied by 3, the new volume will be adjusted by 3 cubed. So the new volume is equal to the original volume multiplied by the scale factor cubed. 3 times 3 times 3 is 27. So 27 times 1,259.9 gives us a result of 34,016.3 centimeters cubed. So in general, if the dimensions of a 3D shape are multiplied by a scale factor of k, then the volume of the scaled shape is k cubed times the volume of the original shape, or k cubed equals the volume of the scaled shape divided by the volume of the original shape. So now we're going to complete this table. A sphere with a volume of 900 centimeters cubed has a scale factor of 4. 4 cubed is 64. The scaled volume would be 64 times 900, which is 57,600 centimeters cubed. In the next row, we have a rectangular prism with a volume of 375 meters cubed and a scaled volume of 3 meters cubed. We can determine the scale factor cubed by dividing the scaled volume, 3, by the original volume, 375. So 3 divided by 375 reduces to 1 over 125. And then we can determine the scale factor by cube rooting this number, or if you prefer, you can cube root the numerator and the denominator separately. So the cube root of 1 is 1, and the cube root of 125 is 5. Next we have a tetrahedron with a volume of 2 cubic feet. We can determine the scaled volume by multiplying by the scale factor cubed. 2 times 64 gives us 128 cubic feet, and we can determine the scale factor by cube rooting 64. The cube root of 64 is 4. So now we're on to surface area and scale factors. Remember, the area of a scaled shape is equal to k squared times the area of the original shape, or you could express that equivalently in this equation. In general, if the dimensions of a 3D shape are multiplied by a scale factor of k, then the surface area of the scaled shape is k squared times the surface area of the original shape. So you can rewrite k squared is equal to the surface area of the scaled shape divided by the surface area of the original shape. Now we need to complete this table. In the first row, we have a surface area of a sphere at 200 centimeters squared. We can find the scale factor squared by multiplying 4 by itself. 4 by itself is 16. The scaled surface area will be 200 times 16, which is 3,200 centimeters squared. In the next row, we have a rectangular prism with an area of 50 meters squared and a scaled surface area of 10 meters squared. We can determine the scale factor squared by dividing 10, the scaled area, by 50, the original area, and 10 divided by 50 reduces to 1 over 5. We can determine the scale factor by square rooting this number, or if you prefer square root 1 and square root 5, you could write that as 1 over root 5, or equivalently, if you multiply the top and bottom by root 5, that would end up being root 5 divided by 5. In this last row, we have a tetrahedron with a surface area of 2 square feet. Scale factor squared is 81. We can determine the scaled surface area by multiplying 2 by 81, which gives us 162 squared feet. And we can determine the scale factor by square rooting this number, which gives us 9. In number 4, if the radius of a sphere is doubled, so that means a scale factor of 2, then the surface area of the sphere is adjusted by scale factor squared, and 2 times itself is 4, so then the surface area of the sphere would be quadrupled, and the volume of the sphere would be determined by scale factor cubed, and 2 times itself 3 times is 8, so the volume of the sphere would be multiplied by 8, or increased 8-fold. In part B, if 35 milliliters of paint covered the original sphere, then determine the amount of paint to cover the scaled sphere. So this volume of paint required to cover the surface of the sphere should scale the same way as the surface area of the sphere. So if the surface area of the sphere increases 4 times, then the amount of paint required should be 4 times the original amount, and we get 140. If the sphere's scaled volume was 80 centimeters cubed, then determine the original volume of the sphere. So the original volume multiplied by the scale factor cubed would give us the new volume. Given the new volume is 80 centimeters cubed, and our scale factor cubed is 8, we can determine the original volume by dividing both sides of this equation by 8. So 80 divided by 8 gives us an original volume of 10 centimeters cubed. So that's it for me for today. I'll get you to do this question, and I'll see you next time.